welcome everyone back to class. There's a quiz online right now, due Sunday at 11:59. I'll also release the homework later today. Just watch out for that. I'll send you a notification when it comes out. Also, for the exam date, I know I told you October 8th before, but the date now is going to be September 29th. I believe it's the day before fall break starts, the Wednesday before. Does anybody have any questions about previous content? Yes.
Well, it's just about dates. So when is the homework due, and then also is the exam in person or on campus?
It's in person. And then the homework is also due Sunday. So when I bring it up today or tomorrow, it'll be then. Yes.
Like what lectures are so what lectures is on the exam?
Oh yeah. So the lecture is up until the exam. So today and Wednesday we're going to cover sampling techniques. Then Friday we're going to do a little bit. If I don't get through all of this content, then I'll do a little bit on Friday, and we'll do an in-class activity on Friday. And the following week it'll be on Chapter 6's content, which is gathering useful data for examining relationships. And then that'll be all that the exam's on. So everything that we've covered up until Chapter 6.
Up until Chapter 6, not Chapter 6.
Including Chapter 6. So not including the next chapter probably. Yeah.
I feel like I remember you saying this at the beginning of the class, but can we have a formula sheet?
Yeah.
Okay.
Yeah, so I'll release the details of the formula sheet in a bit. Do you guys mind if I change my mask to not this one? All right. Because I am dying. All right. Okay. Great question. Any other questions? All right. Okay. So we're getting into some fun content today, talking about sampling and surveys whenever it comes up on the screen. So have any of you participated in a survey or some type of sampling strategy, like some type of polling or anything brought up by the university? Just raise your hand if you've done a survey before. So yeah, pretty much everyone. And so it's an important data gathering tool in statistics and more specifically to social sciences. And so that's what we're going to be talking about for the next lecture or two. All right. So what are we going to learn in these? I just wanted to have some type of kind of outline slide. We're going to learn how to collect and use sample data wisely and appropriately, how to choose an appropriate sample size for a survey, how to create a randomly selected sample, understand when to use different sampling methods, and then also we're going to hear about kind of the downsides of surveys, what can happen if you're not careful, and how to employ it successfully so you reduce the chances of mistakes. All right. So in general, person before me came up with this flow chart of conducting research, and I think it's great, and I actually really align with it here. And we'll see just the little steps of it. It's going to go across the screen. And so first part of any research is is what do you want to answer? What is your research question? What is your main focus that you want to understand? So whether it be determining the height of insects or trying to figure out how long does it take for people to grow up to a certain height for anyone, how fast do they grow? Depending on that, and your research question is going to help narrow down what you're analyzing. The second is identifying the population of interest. And so we're going to see this in a little bit. All right. It's not really working with me today. So identifying the population of interest. So that's great. Figuring out, does your population of interest measure what you are going to research? And so if you're looking at all types of insects, you're not going to try and sample humans to understand stuff about insects, right? That just doesn't make sense. So that's just like a basic explanation of the population of interest, but it can get more scientific than that. Then you want to specify the random variables of interest. So if you want to look at the mean of a population or how variable it is, understanding different quantities in that regard. And then comes in the orange step, and the orange is talking about data collection. So generally what we have is, I'm going to erase this from up here. So generally, one we have is kind of brainstorming and contemplation, where you're coming up with a research question, figuring out what you want to study, doing the necessary research before you even set up a sampling plan in order to get your data. Because if you don't get right here, all the steps down here are not going to go right. And so second is, well, what do you need to do a data analysis? Well, it's in the first part of the name. You need data. So data collection. And in this chapter, we'll be talking about through sampling of surveys. In this regard. Then we're going to collect data from subjects in the sample. So once you're figuring out what type of method you want to use, whether you want to say, I'm going to sample all the people who live in the residence halls on campus, or I'm going to sample all the people who live off campus, say in the Edge or in Hampton Hills or wherever people live around. Or you can just sample everyone across the university uniformly. And then from there, you're going to go into what we've called before as EDA, exploratory data analysis. So whenever you collect your data, like we've been looking at on the previous two homeworks, creating scatter plots, side-by-side box plots, bar charts, tables, whatever, you're going to look at your data and see if there's any initial relationships going on that you should investigate. And then you want to calculate descriptive statistics that summarize the sample data. So these kind of go hand in hand. And the main reason why you want to graph the data first, it's easier to see connections graphically, but also only using descriptive statistics can be misleading. And so when you're doing this step of analysis, you both want to graph, but also calculate stats. I'll say descriptive stats here. Following that, you want to use the descriptive statistics to identify and explain abnormal responses in data. And so abnormal is kind of general here, but really what this means is anything that is out of sorts that you didn't expect to see in in your surveying, whether it be, you know, somebody, a large amount of people saying that they love the candy, they love black licorice, but you know, you think beforehand, well, nobody likes black licorice, so what am I going to do about that? And so this helps you kind of subset and discover more patterns in your data. And then whether or not you believe that, you know, these are representative of your data set, or if they don't represent, there's a couple decisions. You can either remove them, collect more, or collect different data. Following that, you can use inferential statistics to analyze the sample data. So 4 is do inference. Kind of a general step here. But essentially, this is the one that gives you the conclusion about your data set, about one particular aspect of your data set. So I can use a t-test, which takes a look at differing means. I can use ANOVA, which looks at means across different groups. Or if I have categories, I can use chi-square statistics, or so on. And so this will be the stuff that we talk about kind of end of November, beginning December about. And then you want to answer the research question, offer recommendations for further studies. So essentially, what we have is a kind of circular process going on, where so more research. And let me tell you, research never ends. There's always a part where you can kind of break off from the process, but people are always trying to figure out more conclusions, and usually when you uncover a rock, you find more problems underneath that rock than you had before. So just an advice. And so basically we start with brainstorming and contemplation, figuring out what the research question is. Then we collect the data to answer that question. Then we look for initial relationships, what are going on. And then we actually try to answer this question by doing inference. All right, any questions before moving on? All right, so I talked about this a little bit. Data needs to match the purpose. And so one of the most basic rules that we need to adhere to is that you can make an inference or a conclusion about a much larger group if your data are both representative to the questions of interest. So 2 important parts here. If the data is representative, and we'll take a look at that in a little bit, but representative is, it reflects the bigger population as a whole. And so I have some examples down here. Do VT students represent other college students? Well, maybe if you're talking about average GPA first year students, then sure, because all these colleges have kind of similar programs. So I would be comparing, you know, let's just say I compared a VT to NC State or Wake Forest, you know, Princeton or something else. The list can go on. Just a list of colleges going on here generally, and mostly just these bigger colleges because the students reflect about the same amount. And so another question of interest is the proportion of students who go on hikes. Well, no, because Virginia Tech's in a mountainous region, and there's already bias there to say that we probably go hiking more than other places. You know, if I'm trying to compare Virginia Tech, its students at NYU, New York University, then this is going to be an absolute no, that if I'm trying to represent overall college students, I shouldn't just use Virginia Tech students that I want to answer this question. Does that make sense? Okay. All right. So I want to talk about sampling a little bit. I've talked about this work before. We've talked about populations, but I like to put it into a more concrete example. So population, its entire group of units about inferences are going to be made. So suppose, and I'm going to use a pretty big circle. So I've got a circle right here, and this reflects the population. And then I have a whole bunch of data points in here. I'm going to use some blue. Got some blue data points. I got some black ones. And I got some red ones. All right. So this is what my population looks like. And now a sample out of this is if I took maybe just like a small sliver from this and represent that as my sample. And now another word we've kind of discussed, and we've talked about how people have gotten data and analyzed it, and something that has happened this year is the census. And this is where every unit in the population is measured or surveyed. So this is kind of just the perfect sample, right? Because you're getting everyone, you're going to know what your population is, you're going to be able to figure out what population parameters are. But however, most of the time we don't have access to that. And if you want to ask me what is the population of the whole Virginia Tech population, I'm not going to have enough time to sample 30,000, 40,000 people. So I'm going to want to take a sample. And so the picture on the right is talking about, and I want to get this wrong, the Pere David's deer. So it's, if any of you are in biology or anything, you may know the extinct and the wild kind of classification. And so essentially, these are not in the wild anymore. They're bred in captivity, and there's about 8,000 in the world. From what I read off of Wikipedia, so I hope it's telling me the right thing. But the concept is still there. And so in this case, the population would be the total 8,000 deer that they have, because that's all of the deer that we really know about. And so a sample would be, say, hey, if I wanted to take 100 deer and I wanted to measure how much they ate per day. And so what would the census represent here? What would it be a census of this population? What do you guys think? Well, a census of this whole population, because we know how many there are, is the total 8,000 deer. And that would be sampling every single one of those deer out there, and then maybe giving it a unique unit so we know which deer we're actually measuring. One way to do a survey is to do a simple random sample. And you might have heard this in either other statistics class or just other times before, but basically the name fits what it does. It's a simple random sample, meaning a subset of the population chosen in such a way that every sample size of size n has the same chance of being chosen. And so if I was going to conduct a simple random survey of this entire class, what I would do is give each one of you a number, and then I would probably just draw them out of a hat or something and say, I've got number 20, 25, 30, and 34. Let's just say. And so if I'm just drawing it out of a hat, and I'm doing it blindly, every person has the same chance of being chosen to be in my data set. And so as a result of this, a sample survey is a subgroup of a larger population question on a set of topics or a type of observational study. And so the sample survey is kind of just a wide-arching name to doing sampling. And so we'll discuss this in a little bit, probably next class. But we have the sample survey here, and then kind of out of it are multiple branches of conducting sampling. And the first one is going to be simple random sampling. Otherwise known as SRS. And so just some of the small examples of doing a sample survey over a census. Most of the time, you can't even do a census. And so the census of the United States is possible because they have lots of money to funnel into it. And you notice that they only do it every 10 years. And they only do it every 10 years because they can only do it every 10 years. They don't have the money or the resources to be able to keep on sampling this population. And that's where it comes into the speed and time and accuracy. And so with the speed and time, obviously, if I'm going to sample 30 students compared to 36,000 students, which ones do you think is going to take less amount of time? 30, yeah. And so in that case, I can spend more time on these steps, the EDA and inference, compared to the data collection that I might have to spend maybe a couple days on and collecting that data. And then lastly, accuracy. So through some concepts I'll explain a little bit, we can actually gain pretty accurate estimates of the population by using just a much smaller sample size. And this is just one way that statistics is used in the world, is that these estimates are pretty close to what actually happens in the population. And so if I give you 100 students and you tell me about 30 of them, I can give you a pretty good idea of what most of them are like. Something I want to spend a little bit of time on, this is in section 5.2 in your book, is this idea of margin of error. Who here has heard of a margin of error before? Right, so they'll say, oh, the margin of error in this survey is 2.5%. And well, what does that mean? And so, let me just erase, do you guys have all this down right now? If anybody needs to write it down, let me know. And so what this margin of error is saying is if I use the right methods, and so that's important because if I don't do the right type of sampling methods for a technique, this measure can be off. So we already have this idea of an assumption in place. So if I sample 1,600 people, if I sample 1,600 and then the population is millions. So let's just say it's 3 million people or whatever that our population is. I can understand a percentage of the entire population that have a trait, have an opinion. 50% say that they like going to class, 40% say they don't, and 10% say they don't care. So if we're doing like that, 50% like going to class, 40% don't, and we got 10% who don't care. And so out of this, I can develop a margin of error that tells me how accurate these estimates are from this that represent this. And so in this case, so the margin of error, measure of accuracy of a sample proportion, telling us how close the sample proportion is in relation to the population proportion, and at least 95% of all random samples. And so we'll talk about confidence intervals, like I said, in November, so I believe that's chapter 10. But basically, we can calculate a conservative margin of error. And conservative in this case means this band, this confidence interval is wider than it probably truly is. And so the way to calculate the margin of error is to do 1 over the square root of n, which in our case is 1,600, and multiply that by 100% because we have these percentages already. All right. Hold on, guys, just 1 second. My computer has decided to just lose Wi-Fi, so other than that. Well, let's just keep going, I'll watch over that. And so, the way we calculate this will be 1 over the square root of 1600, which is 40, and 1 over 40, I say here is, let's just see here, 1 divided by 40 is 0.025. And so this is 2.5%, which is saying that I have 2% of kind of error according to surveying. According to surveying, I have 2.5%, which means that according to Light, I can be between 47.5 and 52.5%. And this is what this confidence interval represents of the people who like going to class. And so we make these kind of just how I said before, but I have this down the slide, sample proportion minus 1 over square root of n, which is basically what I did here. I did 50% minus 0.025 multiplied by 100, and then that means the lower bound of my confidence interval is 47.5%. And the upper interval is 50% plus 0.025 times 100 is 52.5%. Another way to write it is just 50% plus or minus 2.5%. And people just know that you're talking about this interval that I have here. And so one type of example here is how important is religion to adult Americans? So suppose I'm sampling 1,025 adult Americans, and I asked, well, how important would you say is religion in your life? And I got sample proportions of 56% for very important, 25 for fairly, and 19 for not very important. And so in this case, the conservative margin of error is 3%. Just calculated that. Essentially, as this number, as n increases, the margin of error, I'll just use ME to call it, the margin of error decreases. And so this is the same way in the other direction. And so if you've ever wondered people saying, well, I need to get at least 300 people to answer my survey, the margin of error is really what they're trying to understand in their study. They're trying to get to that percentage where they know that my estimates are going to be this precise. And so this approximate 95% confidence interval of all adult Americans. So not just the 1025, I'm going back to the whole population here of all adult Americans who say religion is very important, is 53% to 59%. And so in this case, well, how do we even interpret this interval? Does it mean that if I do this survey again, I'm going to get a proportion? Let me just erase this here. That's in between, yeah, I'll just use this example again. So is it going to be between 52.5 and 47.5? Well, maybe, maybe not, depending if you do this again. What this means in the long run is that when we do this procedure and we do 1,600 samples again of another random sample out of the population, it's going to capture what this population value is. Let's just say it's 52% if it's true, which is P true. It's going to capture that about 95% of the time. So I do this procedure again, and let's say I get 48 to 53. I get 47 to 49. This one's not in that interval. And it can continue all the way down. 95% of these are going to cover that 52%. So if I did 100, about 95 of them are going to have this population parameter within them. Does that make sense about the correct interpretation? I know I've actually initially had problems with understanding what the confidence interval means. But in the long run is really the key here, is that if you kept on doing this over and over again, this interval would capture that truth about 95% of the time. All right, let me see if I can record again. Nope. All right, well. Let's see here. So I guess for this recording today, I'm going to have this which focuses on me and the board, but I'll also have the slides it goes with, and then I'll put in the video, I'll tell you like at 20 minutes or so I was on this slide or whatever. So talking about sample size with population size here. So if the margin of error, ME, is the desired margin of error for a 95% confidence interval of a population proportion, talking about this is the population proportion. Spelling that wrong. Okay. And so in this case, we kind of reverse this equation around to calculating what my sample size should be. So if I want a margin of error of, let's just say, 2%, then if I want a margin of error of 2%, what I'm going to do is 1 divided by 0.2 squared, which is 0.04. And then I can convert this to 1 out of 4 out of 100. And then, no, that's 20%. Hold on. All right, go. 0.02 squared, which is 0.004. So 1 divided by 4 out of 1,000. No, 2,500. All right, so I'm doing bad at math on the road. Essentially, what you can see is if I have a margin of error about 2%, I'm going to need a sample size about 2,500 in order to get my variability down that low. And so the margin of error for a sample of 625 is 3%, or 3 point, well, I have 4% here. So it's 4% no matter what the population size is. And so in practice, if you're going out and trying to get a representation of your population, if your population size is greater than or equal to 10 times n being your sample size, then the population size has almost no influence on the accuracy of these estimates. Meaning, no influence on these estimates right here. Does that make sense? A little bit? Yes?
Is n just the sample size that
Yes.
you take? Okay.
So lowercase n, and we'll use this, so lowercase n is sample size, and capital case N is population size. Good question. Any other questions? Alright, so sampling methods, getting back to the simple random sample. And so we talked about this before. It's a subset of population chosen away that every sample size n has the same chance of being chosen. Everyone has the same chance of being chosen in this. And so one thing that's great is that it helps ensure that the sample data will be representative of the population, but getting exactly what the population is hard to obtain. So that's why we do sampling. So if I wanted to sample, let's just say, baseball fans, and I believe this is Fenway Park. If you haven't been there before, it's actually pretty small. They have you in kind of together there in Boston. But basically, if I wanted to sample a whole bunch of baseball fans from these games, how would I do that using a simple random sample? What do you guys think? If you were the researcher and you wanted to understand this population, what would you do? Yeah.
You could choose like random seat numbers in the stadium.
Right.
Pick the seat numbers.
So everyone has an assigned seat in this stadium, whether it be from A1 all the way to FF30 or whatever, all the way down the rows. You can number them all, which is basically what you're saying, is using the seed or giving them just a random number. And then you have a random number generator, RNG, to choose how many people, and then you go and give them the survey. And so I'm sure a whole lot of people have heard about RNG out there before. RNG standing for random number generator. Basically, it's a source of randomness. And so in order to sample, there's a couple of steps here that I'm also going to write on the board, because it's important to specifically do these. Is it okay to erase this on the board as well? All right. So how do we sample? It's a sample, so step one. So step one here, develop a probability sampling plan. So we talked about simple random sampling so far. There's other types of sampling techniques I'll talk about in a bit. But let's just say we're going to do simple random sampling. Great. Well, in this case, everyone has the same chance. If I'm using other types of sampling methods, then other people may have higher chance of being in the sample than other ones. Step two is get a list of the units in the population. So basically, what does the population look like? Can I assign all these people a particular number in my sample? And then step three, which actually just does the sampling, is obtain a source of random numbers, whether I'm going to use a table of random digits, whether I assign people RNG, so I go out there and each of you get a number, and then I pick according to a random number generator, or I can do some type of simulation, like random.org does, which is essentially the same thing, but the ways of attaining randomness are different. And this will make a little bit more sense when I have a concrete example. And so a small example of SRS is, suppose there's a population of British women. Let's just say there's 199 of them. I'll erase this from this side. All right. So I have 199 British women. And so I know how many British women are out there, so I can do this sampling pretty effectively. I want to randomly sample 10. So I want to get 10 from this 199. And so first off, I'm going to assign an ID from 001 to 199. And so it's important that you do 001 and 1, because sometimes the computer can treat these two numbers differently. And so whenever you're doing these on the computer or assigning some type of digit, you want to include the zeros in front. So let's just say I have lady 1 here, 001, 002, calculate all the way down until 198 and 199. And so from this, I'm going to use some type of randomness, using random digits to select 10 numbers from this list, and that's who I'm going to sample. So if I'm using Minitab here, as done before, I have IDs of 176, 10, 140, 85, 162, 46, 69, 77, 154. Essentially, just a whole bunch of numbers up here. But what you will see is if I do a random number from Minitab, and if I use a table of random digits, or if I use R or jump to tell me some random numbers or random.org, you are probably going to get a different list with very high probability. And so out of these, I have a whole bunch of heights, but you can see that the means are relatively close to one another in this. And so, within like the type of margin of error, this mean covers what, and with, I believe it'll be about 5% margin of error here with about 199 women with only 10. You're going to have a pretty large margin of error, but you can see that by doing the simple random sampling, you get pretty close numbers. Let's see. I got 5 minutes. Do I want to get into these different types of methods? All right. Well, for the last 5 minutes, I'm going to show you guys a little bit about where you might have seen a survey before. And so one of the surveys here, and I'll increase this a little bit, is the 2019-2020 senior survey that Virginia Tech releases. And so whether or not you're a senior now or will be a senior, you will probably get an email asking you to fill out this survey. And so this is what you think about in your primary major, and it has this type of strongly agree to strongly disagree scale. This is called a Likert scale, and we'll talk about that next time. But essentially, it measures, how many people out of the 1384 within this category, or within disagree, agree, strongly agree, and so on. And so out of this, what I can get is based on the margin of error for this survey. Let's just say I have 50.3. And I'm looking at the people that strongly agree. With intellectually challenged. Alright. So within 50.3. And now I have 1384 responses. And I can create a conservative margin of error of 1 over the square root of 1384. And I'm not even going to try and do that math in my head. 1384 square root. Go. So about 2.7%. So that means I can develop my 95% confidence interval from 50.3 minus 2.7. So between 47.6 and 53%, which is a pretty narrow interval of a majority of people in the survey that think that they strongly agree that this was an intellectually challenging major. So based off of this, I was going to repeat this survey over and over again. Like what they do, this interval will cover the truth about 95% of the time, or the procedure will cover the truth 95% of the time. All right. Any other questions? All right. Well, I'll give you guys this link just to take a look at it if you're curious about how you can use the survey overall. Class dismissed. Yeah, what I'm basically going to do is questions, you guys can ask me any questions. I'll have some sample questions on there. And then I'm gonna have a list of topics that I'm curious that was on there. So I'm not gonna like have an exam.
You can map anywhere.
Calculate this complicated thing I didn't tell you. Yes. Yeah, that's fine. There's nothing like in the calculators that will help you specifically with this.
I was wondering, because I'm horrible at math in my head.
No, you can see how bad I was on math on the board too, so there's no problem.
Okay, awesome,
Did
thank
you
you.
say you wanted me to just email you like the scan of the notes?
Yeah, that's
Like
fine.
Okay.
Pictures, scans, whatever. Appreciate it. Thank and Julia, right?
Yeah.
Alright.
I'm glad I guess I got primed being in this classroom because I totally forgot until I sat in this seat and I was like, wait, I have to take notes. So it's hard on my phone this time, so I like don't forget